Okay, so 6.3, we're going to use the partials. Remember the partial derivatives that we got before? Remember f sub x, okay, and f sub y. Okay, and then out of that, we got f sub xx, f sub xy, f sub yx, and f sub yy. Okay, we took partials of partials. We're going to use this idea today, okay, of the partial derivatives. Okay, partial derivatives. So actually what we call the second partial derivatives, which are these guys here. Okay, second partial derivatives. We're going to use that to find the minimum and maximums of multivariable functions. So 6.3 is maximum and minimum problems in two variables. Okay, in two variables, or we'll say in, yeah, two variables. Okay, there's actually three variables, but okay. Our functions are multivariable functions. Okay, so we call this the d-test, okay, for second derivative test. Okay, second partial derivative test. So it's just called the d-test. It's just the second partial derivatives test. Okay, but d-test for short, because I don't want to say second partial derivatives test. That's too long. Okay, so if f of xy, okay, is a differentiable function, okay, of x and y, then to find the relative maximum or relative minimum values of f, okay, 1, we find the values, find f sub x, f sub y, f sub xx, f sub xy, and f sub yy. Okay, we don't need yx because generally if it's differentiable, if it's differentiable, then f of yx and f of xy are going to be the same thing. Okay, it's going to be a nice function. So we don't need that. Plus, we're not going to really use it in the formula. Okay, so number 2, solve the system of f sub x equals 0 and f sub y equals 0. So we're going to set f sub x equal to 0 and f sub y equal to 0, and then we're going to solve that system of equations, and those are going to be our critical points. Okay, critical, okay, for our critical values. Okay, for our critical values. We're going to have a critical value for x, and we're going to have a critical value for y, or maybe we'll have multiple critical values. Okay. Okay. Number 3. evaluate, yeah, exactly, good memory. Evaluate D for,
Is that you?
no, somebody opened the door, I don't know. Okay, evaluated D for our critical values of X and Y. I should say X comma Y. Okay, for X comma Y, where D, okay, where I'll put D here, D is equal to F sub XX evaluated X and Y times F sub YY evaluated at X and Y minus F sub XY evaluated at X and Y squared. So we're going to find this value of D, okay, if it exists. Okay, this value of D, okay, and I apologize for all the interruptions. Okay, so for D equals F sub F and if, okay, if A, D is greater than 0 and F sub XX is greater than 0, or sorry, is less than 0, then F has a maximum, and a maximum at xy. Okay, so F of xx is less than 0 or concave down, basically. Concave down, then there's a maximum. Okay. B, if D is greater than 0 and F of xx is less than 0, here's your toys and go away. Go with your bad self. The world is against me. The world is truly against me today. Okay. Okay. So if D is greater than 0, if we get a number for D and that's positive, but F of XX is a negative number, okay, then that means that this thing is concave up. Or sorry, it's greater than 0, should be greater than 0. Then this thing is concave up and it has a minimum value. Then a minimum at X and Y. Okay, now what happens if D is less than 0? Well, if D is less than 0, then we have a saddle point at X and Y. Okay, and a saddle point is just that. It looks like a saddle. Okay, it's if I have something that looks like this, okay, but then comes down like this, okay, like that, like that, okay, and then just comes down. Okay, it means that I didn't draw that real well. Like that. Okay. It means that if I put an axis here, okay, if I start from this point 0, 0, if I go, let me change my pen here. Okay, if I go in this direction, I'm going uphill. Okay, I'm climbing the hill, right? If I go in that direction, I'm going uphill. Okay. If I'm going this direction, I'm actually going downhill. Okay, I'm going downhill. Okay. So this direction, I'm going downhill. Okay, so there really is no, if you walk in one direction, you're going to go up. Okay, think of it like here and then here, right? So I won't even put the back of it. Okay, say that you're in between in this canyon. Well, the canyon goes down even further. Okay, and these are the sides of the canyon. And so if you want to go to the right or to the left, you're going to have to go up. But if you go straight forward, you're actually going to go down more, deeper into the canyon. Okay, so it depends on which direction you're moving, right? If I'm moving in the Y direction, I would go uphill. And if I'm moving in the X direction, okay, I would go downhill. So that's called a saddle point. Okay, it depends on where you're at on the saddle. You know, if you're going facing toward the horse, okay, you're going to go up on the saddle. If you're facing toward your legs, you're going to go down on the saddle. So it depends on which direction you're moving. That's called a saddle point. Okay. Just means that we have no relative min or max, right? Like what would a relative max look like in 3 dimensions? Well, a maximum would look like this in 3 dimensions. Say that we had a nice, what we call an ellipsoid. Okay. Okay, and that's a maximum point of that ellipsoid. Or conversely, the ellipsoid could go down like this. Okay, that's the minimum point on the ellipsoid. Okay, so that's in 3 dimensions. Maximum point of the ellipsoid and the minimum point of the ellipsoid. This saddle point has no maximum or minimum. Okay, no max or min, because it depends on which direction you're going. So we just call it a saddle point. You could be going uphill one direction, you could be going downhill in the other direction. Okay, so and then D, if D is equal to 0, then the test is inconclusive. Okay, it doesn't work. Okay, means we can't tell. Okay, let's try an example of this. The saddle point, kind of like an inflection point. I suppose yes. Yes, if you thought of it, well, not really, because it's not changing concavity, because this whole thing is concave up, right, in one direction. If you did slices of this thing, right, if you did slices of this thing, you continue to get slices, and they're all concave up, right, slices in one direction. However, if I took slices in the opposite direction, if I took those slices, okay, if I took these slices, right, Well, those slices are all concave down. So it's not really an inflection point because, you know, you could have a million places here where one direction you're going uphill, but in the other direction you're going downhill. So there's not really one point where it's changing. Okay, so yeah, this whole saddle point thing, you really don't need to know it. What you know, that's more for multivariable calculus, which I'm actually teaching right now as well, but that's for my engineering students, not so much for my business students. So so yeah, so you just need to know that basically if you get a saddle point, or if D is less than 0 or D is equal to 0, test is basically inconclusive for our for what we're trying to do in this class. Okay. Okay, let's do one where we find the values, and then we'll do one where there's actually an application to this whole crazy stuff. Okay. Okay, number 1, find the relatives I'm not seeing any of my relatives over the holidays. That's pretty sad this year. So it's very sad. It's like, okay, so I get to see the same 4 people that I always get to see, and no one else. So that's gonna be fun. Yeah. So I feel like it's like in the Grinch, the Grinch one that came out like, I don't know, 10 years ago with Jim Carrey, where the guy's like, invite the Grinch, destroy Christmas, right? And the mayor Mayhew or whatever his name is, he's like, just invite the Grinch, destroy Christmas. I feel like that's the governor. Invite the governor, destroy Christmas. So anyway, that's my little Christmas rant. Invite the governor, destroy Christmas. Okay. Find the relative min and max of f of let's write it down here. F of xy, okay, equals x squared plus xy plus 2y squared minus 7x. Okay. Okay, so the first thing we need to do is find f sub x and f sub y. Let's do that first. F sub x is equal to what? Is equal to 2x plus y minus 7. Okay. And f sub y, let's find that next, is going to be, well, the x squared is a constant. Take this with respect to y, so that's going to be an x. This is going to be a 4y, x plus 4y. And then minus 7x, that's 0. Okay, plus 0. Okay, and now what I have to do is I have to set these equal to 0. 0. Okay. So what's this going to be? I'm going to toss the negative 7 to the other side. That's going to make it positive. So I get 2x plus y equals 7, and x plus 4y equals 0. So now what I need to do is I need to solve this. I need to solve this system of equations. Okay, does this system have a unique solution? Okay, and if so, what is that unique solution? And is it a maximum or a minimum? Okay, so I'm going to solve this by linear combinations or elimination method. I'm going to multiply both by -2. I get 2x plus y equals 7. Negative 2x minus 8y is equal to 0. Okay, so that cancels. I'm going to combine the -8 and the y. Negative 8y and y, that's negative 7y. I'm going to add 7 and 0, that's 7. Divide by -7, I get y equals -1. Okay. So now I can plug into any equation here that I want that involves x and y and just solve for x. So maybe I'll do that in the bottom one. This one might be a little bit easier to work with. So x plus 4 times -1 plus 0 is equal to 0. Okay. So x plus -4 or x minus 4 is equal to 0. Add 4. And I get x equals 4. Okay, so that's the system. That's the solution to my system of equations, is that there is a maximum, minimum, or a saddle point, or nothing, okay, at 4, -1. These are my critical values. Okay, those are my critical values. So now, whoa. Sorry. My bad. Okay, so now, again, everybody's conspiring against me today. Now I want to know, what is this thing? I know that at 4, -1, okay, there is some there is some relative min or relative max, but I need to know what it is, okay? And the point is not at 4, -1. The point is actually at 4, -1, and then f of 4, -1. Okay, it's in 3 space. It's a 3-dimensional point. Okay, I just haven't evaluated what 4, -1 is yet. Maybe I'll do that now. Okay, so if I were to plug in f of 4, -1, that's going to be equal to 4 squared plus 4 times -1 plus 2 times -1 squared minus 7 times 4. I think that's it. Okay, so this is 16 minus 4 plus 2 minus 28. Okay, so this is going to be 16 minus 4 is -12. This is going to be plus 2. Okay. Oh, sorry, this is positive 12. Plus 2 minus 28. So this is 14 minus 28, which is -14. So I need to know, is that going to be a maximum? Okay, is that going to be a maximum value? Say this is some sort of surface. Is that a maximum value or is that a minimum value? Right? So I don't know. Okay, so this guy is located at 4, -1, -14. Okay. Okay, so now let's run our d-test. Okay, the first thing I need to know is I need to get these partials, f of xx, f of xy, and f of yy. Okay, so what was the partial of x? The partial on x was this guy here. Partial on x was this one here. So if I took the partial on x again, the only thing that would survive is a 2. Okay, so f of xx is equal to 2. Okay, what about f of xy? F of xy, if I did the partial of on y, or sorry, partial of x on y, that would just be a 1 in front of the y. That's the only thing that would survive there. So this equals Okay, and f of yy, okay, f of yy, that's going to be 4, because the 4 in front of the y is the only thing that's going to survive in the second one here. So now we're looking at the second one. Okay, and we're doing f of yy. Okay, and so that equals 4. Okay, so now I want to do the d test. The d is f of xx, f of yy minus f of xy squared. Okay, so this is going to be 2 times 4 minus 1 squared, okay, which is equal to 7. Okay, and 7 is greater than 0. Okay, so that's good, because if we go back to what the d test told me, was if d is bigger than 0, then I'm going to get a min or a max. Perfect. We don't have to deal with those saddle points or anything like that. Okay. But what else do I need to know? Well, I need to know what f of xx is. What was f of xx? In the x direction, it was positive. It's greater than 0 as well. Okay, so that means that it's concave up, which means that it is a minimum value, right? Think of, again, concave up. Okay, f of xx, d is greater than 0, and f of xx is greater than 0, meaning that it's concave up. Okay, like this. Okay, like a cup. Okay, so concave up, which means that I'm going to have a minimum value. Okay, so there was a minimum value of negative 14. Okay, minimum value of negative 14 for this function. Okay, for, maybe I'll say for f of xy. Okay. When x equals 4 and y equals negative 1, right? Okay, so let's do a business application of this. Okay, number 2. Oops. Business. Maximizing profit. I always want to maximize that profit. Okay. A company produces 2 types of golf balls. Okay, one sells for $3 and one sells for $2. Ball. Okay, the total profit for selling X thousand balls, X thousand balls, or X thousands of balls. At $3 each, and Y thousands of balls at $2 each is given by P of XY is equal to negative 2x squared plus 2xy minus y squared plus 12x plus 12x minus 4y minus 7. Okay. Okay, how many of each type must be sold how many of each type must be sold to maximize profit? The profit function. Okay, so how many of each type must be sold to maximize the profit? Okay. So we need to find our partials. So P sub x is equal to negative 4x plus, okay, 2y. Okay, the y squared, that goes to 0 because it's treated as a constant. The 12x goes to 12 plus 12. Okay, the negative 4y goes to 0 and the 7 goes to 0 because those are treated, these three are treated as constants, okay, when we're dealing with x. Okay, P sub y, okay, is going to be 2x, okay, minus derivative of y squared is just minus 2y. Okay, so this goes to 0. Okay, this goes to 0 and that goes, it's going to go to 0. So this is minus 4. Okay, and I can set these both equal to 0 now and solve for x and y. Okay, so I'm going to toss the 12 over and toss the negative 4 over. So I get negative 4x plus 2y equals negative 12. And 2x minus 2y equals negative 4. Oh, that's convenient. It's nice that the 2y and the negative 2y are opposites because I can just add them and cancel them out. This becomes negative 2x is equal to negative 16. Oh, sorry, not negative 16. Is it negative? Oh yeah, this should be positive 4. This should be negative 8. Okay. And so divide by negative 2. Okay, and x is equal to 4 again. So x equals 4. Now I just have to figure out what y is. Okay, so let's just plug into maybe the bottom equation. I don't know. 2x minus 2y equals 4. Plug this in here. So 2 times 4 minus 2y equals 4. 8 minus 2y equals 4. Subtract 8. Negative 2y equals negative 4. Divide by negative 2. And we get y equals 2. Okay, so we have x equals 4. And y equals 2. So those are my critical values. Okay, I don't know if those critical values are going to create a maximum or a minimum. Okay, or a saddle point. So I do need to do a d-test on this. Okay, in order to do the d-test, however, I am going to need to know what f of x is, what f of y is, and what f of xy is. Okay, so what was, or we'll say p in this case. That's the variable we're working with. Okay, so let's take the partial derivative of x with respect to p of x with respect to x. Well, that's just going to be only one term is going to survive. That's the negative 4. So this guy's negative 4. What about with respect to y? Well, the only term that survives there is the negative 2. Negative 2. And then what about if we take the top one with respect to y, that's going to be a positive 2. Positive 2. Okay. So okay, so now I'm going to run the d-test here. D, okay, d is equal to p of xx times p of yy minus P of XY squared. And I want to see, is this thing going to be positive? If it's positive, then we have a maximum or a minimum. Okay. Okay, so P of XX is -4. P of YY is -2. And this is minus 2 squared. Okay, so this is going to be 8 minus 4, which is 4. So D is 4. So D is positive. Okay, so we have a min or a max. Okay, but what's P of XX? P of XX is -4, which is negative, which means that this is a maximum. Okay, there's a maximum value right here. Okay, so there's a maximum there. Okay, so we found a maximum. Maximum occurs when x equals 4 and y equals 2. Okay, so what does that mean? That means that we're going to sell 4,000 $3 balls and 2,000 $2 balls to make a max profit of, I don't know, let's plug this in. P of 2 and 4, okay. We could do P of 2,000 and 4, 4,000 and 2,000 if we really wanted to. Okay, however, I don't know if that's, I think we need to do the P of 2 and 4, because that's how it was originally set up. Okay, is equal to -2 times, okay, go back to the original equation here. Okay, -2, it's right here. Get rid of my markings. Okay, -2x squared plus 2xy minus y squared. Okay, so minus 2x, x was 2 squared. Okay, plus 2xy, which is 2 times 2 times 4, minus y squared, that's 4 squared. Okay, plus 12 times x, which is 2, minus 4 times y, which is 4. Was x equal 4? Oh, yeah. Oh, yeah, I think you're right. I think it was, yeah, 4. Sorry, 4 and 2. There we go. 4 and 2. Okay, and then this guy is 2. Okay, 4 and 2. Okay. I think those commas messed me up. Yeah, 4, x is 4, y is 2, and then minus 7, right? At the end. I think there was a minus 7 here. Yeah. Okay, so we can just evaluate this. You can plug all of this into a calculator and you're going to come out with 13, okay, in the very end. Okay, and so, okay, however, this is in thousands, okay, and so this really is $13,000. Okay, it's 13,000s. Okay, the units is in thousands of balls. And so if you get $13 per ball, then it's 13,000 per thousand, balls. So $13,000 is my maximum profit. Okay. Yeah. And the only reason we couldn't use thousands here, the reason that we couldn't plug in thousands is because of this 7. Because that 7, you'd have to, if you wanted to, you would have to translate that 7 to 7,000. If you want to plug in thousands here, you would have to translate that 7 to 7,000. And then you would come out with the same answer. But the units are such that it's in thousands. But at the very end, this is 13,000s. So I just changed it to $13,000 because profit is in money. Okay, and that's it. That's all of the entire course. So we'll review on Thursday and then take our final on Tuesday, okay? There you go. You guys survived. Okay, welcome. I'll see you guys on Thursday. Okay. Office hours on Thursday and Tuesday. Thank you. You're welcome.